Live now.
Okay, hello, all of you. इतनी देर से like all of you were waiting out there. Like there are so many people who were visiting us, and not like daily we were getting phone calls about this wonderful event which was happening today. Like we are all excited to meet Dr. Lau, like Graham Lau sir, who is a wonderful astrobiologist, and like he has been associated with us at Kalam Labs. And I'm truly excited that Aaj we'll be getting certain facts, certain answers that is Jadoo, like all the aliens or all the things which we have seen on TV or stories or magazines or whatever it is. We would be knowing now that what is the real truth behind it. So now this is the time of redemption, is the time of truth, and we shall be knowing all these wonderful things in this today's session. My name is Harshit Avasti from Kalam Labs, and with all my like people, I'm truly excited for this session. And Dr. Lau would be joining us as of now. So he's living in USA he's joining us from Colorado, and it's 7:30 a.m. Okay, so it's a.m. that side of the world, and I hope that this session will be quite amazing. Please let us know in the chat section that what's happening out there. Yep, Divyansh, Pawar, like wonderful. Hi, hello, all the people who are in the chat section. Please let us know what's going on, and one like and all the things which were happening. It's really great to see so many people out here. So, guys, please let us know all the people who are as of now here. Like, please hit the like button, and also because it will help us to reach ज़्यादा से ज़्यादा लोगों को. And क्या लगता है like क्या आज आंसर मिल पाएगा like to the wonderful question जो हम लोग हमेशा से देखते आ रहे थे. Like क्या रोहित का जादू रियल है? क्या आप सही में एलियंस एग्जिस्ट कर सकते हैं, और अगर कर सकते हैं तो कैसे एग्जिस्ट कर सकते हैं, उनके पीछे की क्या क्या सारी साइंस होगी. एंड लेट्स सी दैट हाउ नासा, इसरो, ऑल दी स्पेस बॉडीज विच आर आउट देयर, हाउ आर दे डीलिंग दिस प्रॉब्लम. लाइक मतलब क्या वो भी ऐसे कोई मशीन बना रहे हैं लाइक जैसे हम लोग ने अभी तक देखी हुई है, जिसमें हम लोग वी कैन कम्युनिकेट विद सैटेलाइट, रेडियो, टेलीस्कोप एंड ऑल दीज थिंग्स. So Aj, we will know each other on this platform, which is known as Kalam Labs, and we have a very wonderful surprise for you. So in this session at around 8:30, we have something very special for you, in which we'll be showcasing your new thing. अभी तक हम लोग ने गेम्स बहुत सारे खेले थे, अभी तक हम लोग ने बहुत सारी चीजें देखी थी, अभी तक अब बुक्स अलग होती थी, पढ़ाई अलग होती थी, सब कुछ अलग होता था. बट इस टाइम पे वील शो यू योर ओन सोलर सिस्टम, हाउ इट्स पॉसिबल. Wait till 7:30 and then something amazing is gonna come. Wait till 8:30. 7:30 तो ग्राहम सर क्या का टाइम है, मैं खुद ही कंफ्यूज हो गया. Yep. So wait till 8:30 and उसके बाद हम लोग को पता लगेगा कि एक वर्चुअल ऐसी चीज, एक आपका खुद का सोलर सिस्टम एंड खुद की स्पेसशिप अगर होती तो कहाँ जाती है. So this is the question for all the people in the live stream. Please let me know that what if you have a spaceship. Okay, imagine you have a spaceship and you want to go where. Okay, like recently अभी हम लोग ने देखा था कि Saturn and Jupiter का conjugation हो रहा था. So अगर आपकी एक spaceship होती, अगर आपके पास एक खुद का vehicle होता like PSLV or GSLV or the Challenger rocket which was launched by NASA, where would you have like कहाँ जाते आप लोग किस साइड पे जाते? would you travel towards Mars or Jupiter or Saturn, या Pluto चले जाते, या फिर दूसरी galaxy चले जाते? Please let us know in the chat section and let me see the answers. Okay, wonderful. Jupiter, Mars. Okay, a lot of people are telling me that Mars is the correct answer. Aliens exist. Wonderful. Like Sonika Dubey, Vinod, Alka, Adhiraj, Sheetal, Kiran, Ananya, Lakshya, Sharik, Kanhaiya, all the people who are telling us that they wanted to go to Jupiter, Saturn, and everything. Graham sir is going to join as of now, and at 8:30, there's a big surprise. Okay, like हम लोग के जो क्वेश्चन है ना कि अगर हमारी खुद की स्पेसशिप होती और कहाँ जाते, लाइक मैं शायद मार जाता, उसको हम सही में अनरावल करने वाले हैं. हम लोग की खुद की एक स्पेसशिप होने वाली है और हम लोग उसमें खुद जाएंगे. कहाँ पे जाएंगे? जहां पे आप ले जाओगे. कैसे बताओगे? इन द चैट सेक्शन, देयर इज अ चैट सेक्शन एंड देयर इज अ लाइक बटन जिसको आप हिट कर सकते हो इफ यू वांट, एंड we can let us know that what you want. Now, let's see what's the answer coming on. First go to Mars. I'll first go to Pluto. Pluto. Okay, guys, one question. Okay, I know it's a very easy one, but I'll be asking such questions throughout the session. Okay, to test whether you are at least like, अगर आप लोग aliens को जानना चाहते हो तो क्या आप ready हो space में जाने के लिए? 8:30 को जो हमारी ship आने वाली है, like with which we will be virtually traveling towards Jupiter, Pluto, and beyond. Are you ready to be a part of it? So एक क्वेश्चन है आप लोग के लिए Like, is Jupiter a planet or not? The first 10 people who will give the answers, perhaps we will give them a chance to come on the Zoom call. Okay, so let us know. And ये हम लोग 5 सवाल पूछेंगे throughout the session. And सबसे ज़्यादा जो correct answer होंगे, people are watching you in the chat section. Perhaps you can see a person with the name Kalam Labs who is asking, like, our YouTube channel is basically answering your answers, like seeing all of the things which you're going. And yes, 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 yes. Wonderful, 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 wonderful. So guys, प्लीज लेट मी नो व्हाट डू यू थिंक, इज प्लूटो अ प्लैनेट और नॉट? अगर आपको लगता है प्लूटो प्लैनेट है तो यस टाइप कर दीजिए चार्ट में, और अगर आपको लगता है कि प्लूटो प्लैनेट नहीं है तो नो टाइप कर दीजिए। ओके, एंड इस तरह के और क्वेश्चंस आने वाले हैं जिसमें विल टेस्ट whether you are ready to this journey, and as we have told before. Okay, so hello Graham sir, how are you?
Hello. Quite well,
So
thank you. How are you?
yeah, like, so what time is it, like, Graham sir, at your like place?
It's only 7:30 a.m.
Whoa, wonderful. Like, it's in all the, like, in India, it's around night, it's beginning of the night. And
Mhm.
all the kids, like, I must tell you that, like, we have around 1,300 people watching us live, and we shall be beginning our session with some wonderful questions. So,
Sounds good.
like, yep. So, like, I'll give a brief introduction about Graham, sir. Like, he's basically Director of Communications and Marketing at Blue Marble Space. He's also a research scientist at the same association. Blue Marble Institute of Science basically deals in astrobiology. So this is the science which basically deals with alien life, the origin, and all these things. And he's a host of a very famous astrobiology show, of which I'm a great fan itself, like Ask an Astrobiologist. And we are like, it's a weekly show which comes on the channel NASA Astrobiology. And we are totally grateful to have you, sir, with us.
It's a pleasure to join you.
Yep, yep. So like, how do you feeling, like, as of now, like, in our this session, like, people are so, like, you must have seen in the, like, timer YouTube video as well, that people were posting a lot of question hits and likes of, like, what are the things were happening. So are you like, what's your reaction towards this chemistry among the kids?
To everyone posting on YouTube.
Yep.
Yeah, I mean, there's a lot of great questions already. I've tried to answer a few of them. There's a lot of really intriguing questions. I was just answering one. One young person asked if we could send missions to other planets, just like Mangalyaan, or Mars orbiter mission. The first of which was extremely successful. Hopefully, everyone knows that India is the only nation to have had a successful launch and mission to Mars on its first try. The other three organizations, NASA, Roscosmos from Russia, and the European Space Agency, have never had a first successful mission to Mars. But the answer is there's a lot more to do. ISRO is only beginning. There's a lot more missions to come. The second mission, the Mars Orbiter 2 mission, is coming soon. And so for people who are asking questions like that, it's super exciting. There's a lot more to come. For those who are interested in astrobiology, and how we're searching for the possibilities for life out there and how we're learning about life here, there's so much more to learn right now. We're only just beginning.
Yep, yep, yep. So, like, Graham sir, I'll like, as some of the audiences are, like, quite young as well, so I'll be using some Hindi anecdote as well in order to, like, make it more understandable. So Graham sir अभी कह रहे थे basically, like, he's very proud of the Mangalyaan mission, जो अभी Mangalyaan mission हुआ था, and he's totally proud of it, and it's something which is really good. So now, like, like, in throughout these sessions or the comments, we find this question, like, are aliens real or they exist or not? So that's the buzz question within all the kids. Like, since our childhood, we have been saying Area 51 and all these stuff. We see Discovery documentaries and all these things. So what do you define by it? Like how you take up this question and how you think we should take up it as well?
Yeah, it's a great question. The immediate answer is that we don't know. We don't know if we're alone in the cosmos or not. And if you're thinking like a scientist, if you're thinking logically and you're using reason, you have to admit that we could be alone. We might be the only life in the universe. To our knowledge right now, life started on Earth at some point very early in our world's history. And life has been evolving and changing here with this world for a very long time. But to date, we have not discovered any alien life out there. We have no signs of extraterrestrial life yet. However, if you just start looking at the possibilities for alien life out there, like consider the number of worlds in our galaxy. When I was born, we didn't have any evidence of worlds around other stars. We'd never found any exoplanets. And now it's over 4,000, easily over 4,000 exoplanets that we know of. And that's telling us, and we're only looking at a very small number of stars. And so these worlds are telling us that there must be many, many, many planets in our galaxy. So much so our current estimate is maybe more than 1.5 planets on average per star, maybe 2 or more planets per star, which means that if we have 100 to 400 billion stars in our galaxy, we start looking at many hundreds of billions, maybe even 1 trillion or more planets in our galaxy. And that means there's a lot of potential places where life could start. And if it does, and that happens fairly commonly, then there could be life everywhere out there for us to find. But in regards to things like the Discovery Channel, the History Channel, and some of these television shows, Ancient Aliens, I'm not really a fan of those ideas because there's no support for those beliefs. The Ancient Aliens idea itself, it's an older idea, but most of it's come from a guy named Eric von Däniken. He's from Switzerland. And he wrote a book called Chariots of the Gods back in the middle of the 1900s, where he proposed this idea of ancient aliens, but he didn't really base it on any actual archaeology or knowledge of history. He really just was looking at things like Pakal's tomb from the Mayan Empire and things like this, and he saw what he thought looked like spaceships in ancient archaeology and in ancient stone cuttings and things like that. One of my biggest problems, I think, with the idea of ancient aliens is that it presumes that ancient people were not advanced, that they weren't intelligent, they weren't capable. But if we look back at our ancestors across the planet, were very intellectual people. They wrote music and poetry and great epics and sagas. They created great constructions around the world. And I think it's actually kind of unfortunate, and it's kind of, it takes away from the beautiful culture that we have by suggesting that it had to be aliens. It couldn't be humans working together to solve these problems. So I don't personally believe in it. However, if you ever do have a chance to visit, you can't go to Area 51, obviously, but you can drive beside it. It's out in Nevada here in the US. There's a highway called Extraterrestrial Highway that goes right beside it. It's a really beautiful place to go to stargaze. So the night sky is very, very dark out there. There's not many cities around. The closest big cities are Reno and Las Vegas. And so it's very dark. And so if you like going out and seeing the stars at night, it's a great place to go. And if you're into the idea of alien visitation, you could also just watch the sky at night and see if you see anything.
Whoa, like that's a wonderful revelation, sir. Like in our childhood, since we were like 10 or 15 years old, we have always seen this Discovery series, like Area 51 is doing that, it's doing that. So Graham, sir, like when you were of the age, like one of the, like most of the audiences are basically 10 to 16 years old. So like when you were of our age, so what was your motivation towards the alien life? Like, were you also motivated by these sci-fi things, like what is shown on the popular science channels, or you had certain different motivations?
Absolutely. I was very much inspired by science fiction. I grew up, I love Star Trek. I love Star Wars. I grew up reading comic books and novels in science fiction. I loved Isaac Asimov and Arthur C. Clarke. Their works were fantastic for me. Robert Heinlein was wonderful. I really enjoyed reading Carl Sagan's work when I was a child. So Cosmos, Pale Blue Dot, and then later on, A Demon Haunted World. These books really inspired me to want to learn more. And also watching things like Discovery Channel. I remember there was a special, I want to say it was 1994. There was a special on television called Solar Empire. And it was a documentary series about space exploration and planetary science. And I had a VHS. This is an old system, long before DVDs, and then long before we had as much of the internet and storage now that we do. We had these little cassette tapes. And I recorded all of this documentary on these cassette tapes, and I watched it over and over again. It was narrated by a man who played a character on Star Trek called Worf. The man's name is Michael Dorn, and I loved his voice. I loved hearing him narrate, the science. And it's weird now. I bet if I go back and watch those tapes now, I bet a lot of the science has changed. Because science is an evolving thing. It's a progressive thing where we keep learning more and more about our place in the cosmos and the worlds that are out there. And so the things that inspired me as a kid might be things that are kind of, yesterday's news. The things for all the young people watching right now, I mean, there's big things. Like I said, but back then we didn't know of any of these exoplanets. We didn't know of any of them around these other stars, and now we know of over 4,000. That's changing the game. What we're learning along the way about ourselves and our place in the cosmos, the history of life on Earth, it's all changing all the time. And so we always need more people to get involved in the conversation, in the research, in the interpretation, and try to help us learn more about what it means to be human in this cosmos.
Wow, that's truly amazing, sir. So, in the past conversation, like you said, like your interest towards exoplanet, and I've heard your previous podcast and science shows, sir. So, I have the idea that your area and like most prominent area of research is perhaps the research of life in the exoplanets. And many people on YouTube, they are also asking us that the term, what is exoplanets? Like, are there even planets beyond Neptune? And like these, like all these questions are coming. So can you like explain what's happening around in these weird outside worlds?
Absolutely. I should say first, my primary background in research is actually in geochemistry in
Okay.
polar environments here on Earth. But the
Mhm.
cool thing about astrobiology and about anything you wish to do in your life is you can study everything. You can learn
Okay.
a bit about everything. There's no reason to stop yourself from learning about everything. And so I am very intrigued by exoplanets. And so for those who are asking, an exoplanet is a planet beyond our solar system. So these are also sometimes called extrasolar worlds, worlds that are beyond our solar system. They're planets that are orbiting other stars. Most of them are very close to us in the galaxy. Due to how we've been looking for planets so far, we've mostly been looking. You have this big galaxy, which is like one little corner of the galaxy that we're looking in right now to find these planets, because it's really hard to look other places right now for us. But we're getting better and better at it. There are more upcoming telescopes that will look for more planets out there. I have a feeling in the next few decades that that number of 4,200-ish planets will jump to 10,000, before long 50,000, then 100,000. And who knows, maybe by the time all of our young viewers have grown to be old, they'll be teaching their great grandchildren about the millions of planets that are out there that we know about.
Wow.
But the cool things about these worlds is that they're teaching us so much more about how worlds form around stars. They're teaching
Wow.
us more about the potential for life out there. So before we started finding these exoplanets, it was very much assumed in planetary science that the worlds of our solar system, for the most part, are still where they were when they were created, when they were formed out of the disk of dust and gas around our star. But one thing we found out very early on in looking for planets out there is that the ones that were easiest to find were the ones we call hot Jupiters. They're worlds about the size of Jupiter, and they orbit very close to their stars. Some of them are orbiting around their star in just a few days. And so that'd be just like cripplingly fast, flying around their stars. And these are worlds that are full of gas. They're giant, massive worlds. And so they told us we had to go back to the drawing board and think a bit more about planetary formation and planetary evolution, and the fact that planets most likely can move in their orbits. And we now have good reason to think that early in the history of our solar system, Jupiter and Saturn most likely did some moving. And there's even some ideas out there could have been some other planet-sized bodies in our solar system that got either kicked out of our solar system entirely, or maybe got shoved a little bit further away into long, 10,000 year orbits.
Wow.
So you
That's
might have heard Konstantin Batygin and Mike Brown recently, a few years ago, proposed that there could be other worlds, maybe even as big as Neptune, further out in our solar system that we just don't know about yet. Because they'd be so far away, they'd be extremely dim. We wouldn't see them very easily. But because of how other worlds in our solar system appear to be moving, it seems like it could be mathematically possible, at least, that there could be a world-sized object out there. And so they've been actively looking for it each year, using telescopes in Hawaii and other places to look for the potential for this other world out there, maybe more worlds out there. There's so much about the outer solar system we really, really don't know yet.
wonderful. Like it's truly amazing. So, sir, like you're trying. So, all the young viewers, like in Hindi, I would say that जब सोलर सिस्टम बन रहा था देन उसके टाइम पे कई सारे प्लैनेट्स थे जो हम लोग के सोलर सिस्टम से बाहर चले गए सो व्हाट सर इज सेइंग दैट दे वर लाइक अदर प्लैनेट्स एज वेल ड्यूरिंग द फॉर्मेशन ऑफ सोलर सिस्टम एंड दे वर किक्ड आउट ऑफ द सोलर सिस्टम ड्यू टू ग्रेविटेशनल इन्फ्लुएंस एंड ऑल दीस थिंग्स like it's so like so what one question in that aspect is that if these worlds are kicked out of the solar system and they do not like they are not near to the sun, then how can we say that the possibility of life is greater on these planets, or perhaps why are they more interesting in terms of alien life formation or like other things? Like what are the factors? Is there other sources of energy apart from sun which can be used as a life form?
Yeah, so I think there's a lot of reason to look in our solar system for extraterrestrial life. Very early in our solar system, I personally think if there was another world besides Earth that most likely had life, it was probably Venus.
Oh,
Very early on, Venus was most likely a lot more like the Earth, very close in size and composition. It might have had oceans. It might have had a very nice atmosphere for life to form in. And so Venus could have been a great place long ago. But in the intervening billions of years, in the eons that have passed, Venus has undergone some very drastic changes. Its surface appears to have melted out entirely, some hundreds of millions of years ago, and that would have melted most of the rock, maybe all of the rock on the surface, and probably killed a lot of things. And then it appears to have undergone what we call a runaway greenhouse effect. So the atmosphere of Venus is very thick and very hot. The surface pressure on Venus is 92 times the surface pressure here on Earth. That's like going down a kilometer down into the ocean and having that pressure squeezing on you. And then the temperature there is about 460 degrees Celsius. It's very, very hot on the surface of Venus. And so Venus is now kind of inhospitable for life at the surface. However, you might have heard recently there's some idea that there could be life in the clouds, in the atmosphere of Venus.
yeah.
And then also like looking at Mars, Mars might have had life long ago, and maybe it still does. Maybe somewhere in the subsurface of Mars, there's some refuge where life still
Whoa.
thrives. And so we need to go there and search. And then a lot of us are really intrigued by the icy worlds in our solar system, Europa, Enceladus,
Yeah.
Titan, these worlds that have ice-covered surfaces, but oceans down below, and oceans that might also have life. And so we don't know yet. There could be alien life in our solar system to find. But if we're looking for a world like Earth, if we're looking at a rocky world that has a biosphere all around, the entire surface of Earth, I mean, up into our atmosphere, deep down into the subsurface on the crust of our world, there's a biosphere. Life is abundant and it's everywhere, and it's affecting the world. It's changing the atmosphere. It's changing the chemistry of our world. And so if we're looking for a world like Earth, we're not going to find that here in our solar system. So for finding Earth-like worlds that might be out there, that's one reason that we're very excited about exoplanets, because there could be Earth-like worlds, these terrestrial worlds with abundant biospheres active on their surfaces, maybe with oceans and clouds, maybe with atmospheric compositions of chemicals, of the molecules, the gas in the atmosphere that actually show that life has been doing something, life is active on those worlds. And so that's a really cool reason to go look at exoplanets.
Whoa. So, there's one question which has been there. So, there's like huge possibility of life around, like perhaps a proto life in Venus or Mars. So, but there are also like some things which have been like in the sci-fi or like children's used to read about them more is the alien sightings. So, it's a very non-scientific or perhaps a popular question, but perhaps most of the viewers are like having this such kind of question. So, what do you believe in all these stories or perhaps things which have spread on internet or on a TV of weird UFO and all these things happening? What's your perception of alien life? Do you think they are like slim, big-eyed, like humanoids, or perhaps it's a bacteria or something which we are looking? Yep.
Yeah, so let's break that into two things. One
Yep.
is alien visitation. The other is what might aliens be like.
Yep.
With alien visitation, I've been a long-time stargazer. I love watching the stars at night. I love watching the movements of the planets and the phases of the moon. And if you just spend some time outdoors in dark places and you look at the sky, inevitably you're going to see something you can't explain. It's happened to me many times in my life. I've seen weird flashes of color in the sky. I've seen things like meteors that come through the sky and then zigzag and do all kinds of weird movements and patterns. And the thing is, when it comes to UFOs, these unidentified flying objects, and the more common term that you're going to start hearing now is unidentified aerial phenomena, or
Okay.
UAP. because we don't have reason to think that all of these things are objects, which is why we're moving away from the term UFO. Because some of these things could be sunlight glinting off the window of an airplane or a jet high up in the atmosphere, and then shining back through the clouds. And the way the light moves through the clouds can actually cause a lot of these things that we're seeing. We've also discovered that shooting stars, meteors, when these little grains of dust and little grains of ice and sometimes even larger rocks. I have a lot of meteorites over here myself. I love meteorites. When these things are coming down through our atmosphere, they don't always follow a straight path down. Sometimes, because of the way that gas can be stored inside of them, the way that they're burning up and friction is affecting them, they can actually go sideways. Meteors can make a zigzag pattern. There's a lot of weird things that we actually have very good physical explanation for in our atmosphere.
Okay.
That said, there are still a whole range of these unidentified aerial phenomena that we cannot explain. That doesn't mean it's aliens. It most likely means that it's physics. It's probably something happening in physics or chemistry. So you might have heard of the aurora borealis or the aurora australis. These are the northern lights and the southern lights. These are the lights in the heavens at night, especially in the polar regions, when particles from the sun are coming down through our atmosphere, interacting with the gases like oxygen and nitrogen, and exciting these gases and causing them to turn these very beautiful colors. There could be other phenomena like that are occurring that we just don't quite understand fully yet. It's a good reason to study physics and to learn about atmospheric chemistry and atmospheric physics. That said, I also don't think, I never want to question someone else's personal belief. If you believe you've seen something and you think it's an alien, that's fine. But because you believe in it doesn't make it necessarily real to the rest of us. And so the only way for us to really know is to research it. And so because of that, there are a lot of us who have advocated for more active research of these unidentified aerial phenomena. And I would never be one to say it can't be aliens. I think it's probably not, but that doesn't mean it can't be. And so again, we should look, we should find out. But I'll tell you what, one reason why I think it's not aliens. If aliens were intelligent and they had the capability of building spaceships that could travel between stars, so very highly advanced compared to us, the time it takes to travel between stars is very long. And so it's very unlikely that they're taking a slow method. They probably have more knowledge of physics than we do. So if they can travel from one star to another, and they can come to our world and then for some reason fly through our atmosphere, and if they really, really don't want us to know that they're there, then we would not be seeing them. Otherwise, they're not very intelligent. Because if they're intelligent, then they would be hidden and we wouldn't see them. And if they're not intelligent, then they can't travel through the stars. And so it creates a paradox where I don't believe it's actually likely that these aliens are doing this. However, that said, I do feel like given the potential for life out there, that there must be some other life. It feels, as a human being, considering the cosmos, when we look out there, it feels like we can't be alone. And so if there are other things out there, we really don't know yet what to expect. Just because life on Earth was unicellular, it was microbial life for almost all of the history of our planet. Through almost all the history of life on Earth, it was almost all just little cellular organisms across the surface of our world in the ocean. And then eventually we started evolving more complex organisms, and the phyla of animals came around, and then things like us emerged. And so, but we don't know if that's common. It might be that we were very slow. Maybe for some reason, Earth is a slow planet, and many other planets go from microbial life to more advanced animal type life very quickly. Or maybe most worlds out there are only microbial life. I think we have good arguments to believe it's the latter, that there's more microbial worlds out there, especially if there's life in icy worlds and icy oceans. There might not be as much energy available for biospheres to become as rich to allow for larger organisms, but we just don't know. One thing we can assume though, so based on the laws of chemistry, the laws of physics, we can assume in our universe that alien life probably follows these laws as well. And so most likely we're going to see organisms out there, if they are out there, that have evolved and adapted to their environments. However, again, as a science fiction fan, I love to also think of what's possible. Maybe there's a planet out there where the whole planet is one organism and it has a consciousness and the whole thing can speak, just like in Solaris and some other sci-fi stories. Maybe there are organisms that have other ways to tap into the universe around them to see more parts of the universe than we're seeing. So our perceptions are very much what allow us to understand our place in the universe, and our perceptions are limited. We've evolved biological perception to taste and to feel, to see and to hear, but we've also used science and technology to allow us to perceive even more. Now we can use microscopes to see things that are very small and telescopes to see things that are very, very far away. It also has allowed us to look into radio waves and infrared, ultraviolet, X-rays, gamma rays, all of these different realms of perceiving our universe. We're now looking at gravitational waves as a way to see part of our universe. But maybe there's organisms out there that have some of these things already built in. And so maybe their perception, their understanding, and their biology is very radically different than ours. And so it'll be intriguing. We need an example of alien life. Once we have one example of alien life, it gives us the chance to start comparing and to start figuring out a universal law of life.
Wow. So like in your imagination, like how do you, like if you imagine an alien, so how it could be, like whether it's a lean humanoid figure which has been shown in a lot of science fictions with huge bulgy eyes, or perhaps it's some kind of a microbe which we are trying to discover in some far off planet's cloud. So how's your perception? Like if there's an alien, then it should look like this.
Yeah, I think it's very unlikely that aliens will look like us. I think it's unlikely to have two eyes, a nose, two arms, two legs, to be roughly 2 meters in height. Those things are very common to us, but maybe alien life is much taller. Think about the dinosaurs. Many dinosaurs were very tall. Not all of them. Some were short, but many were tall. And then there's other life forms that are much shorter than us. And if an organism develops in other worlds with different gravity and different chemistry, we have no reason to assume that they would form like us. That said, there most likely is, or there are going to be cases of convergent evolution.
Okay.
So this happens on Earth a lot, where sometimes something that life does works so very well that evolution has a reason to converge on it from different directions. A good example is flight. So bats are mammals, and then we have birds who came from the dinosaurs, obviously, and they have flight. At least most of the birds do. And they evolved this separately. They didn't evolve along the same pathway to fly. They evolved flight separately. That means that flight is a convergent process, that there's a good reason for organisms to evolve the ability to fly. I personally think that trees, I think, are probably converging on some universal thing that's very powerful for life. If you think about what a tree does, so plants are using sunlight, they're using starlight to go through photosynthesis and to create their energy. So that they're taking sunlight that hits them and they're turning it into their cellular material, into their energy that they can then use. Mm-hmm. What a tree does, a tree gets closer to the starlight. So you have all these little plants, bushes and ferns and things down on the ground, mosses, and now all of a sudden you have trees that can grow up really, really, really high above the ground, and they can stretch their chlorophyll organs, their leaves and fronds and branches out further and further to try to reach up for that starlight. I wouldn't be surprised if there are alien tree-like beings out there, and maybe they've grown very, very tall in comparison. Maybe they live in a world with different gravitational characteristics, or maybe they've found a way through biology to solve the problem of tree height. And maybe they've grown to a kilometer or 2 kilometers or 10 kilometers in height. That's quite possible. The only thing holding them back then is the revolution of their planet. I think that's very likely. When it comes to movement, so having legs, having appendages that allow a being to move across the ground, that appears to be something that most likely is convergent. It's very likely that alien beings, if they evolve larger multicellular bodies, they probably learned how to walk at some point. Swimming is the same thing. But there are other things as well. So metabolism. Life as we know it, at least, has metabolism. It requires taking in materials for energy and then getting rid of our waste after we've used these materials for our energy. And this is metabolism. Now, we don't know if metabolism as we see it across the planet, the different types used by microbes or by life like us, is going to be common. There could be other forms of metabolism out there. And so we still aren't quite sure what's possible. But it does seem likely that at least some of the kinds of things that we're doing here on Earth have happened elsewhere as well. The different kinds of chemicals that life can use for metabolism, it's probably likely that life somewhere else has figured that out as well. And again, senses too, sensory perception. There are things on Earth that perceive differently than me, or differently than you. One of my favorite examples I love to share, especially with young people, there's an animal called the greater wax moth. It's a small moth that has the greatest known range of hearing. And so we humans, we hear roughly about 5 hertz or 5 waves per second of sound hitting our ears. Out to about 20,000 hertz. 20,000 hertz is 20,000 waves per second hitting your ear. It sounds like a very, very high-pitched sound, a very high frequency. And that's all we hear is roughly 5 hertz to 20,000 hertz. But if you have a dog, dogs can hear out to 50,000 hertz or 50,000 waves per second. And there are organisms like bottlenose dolphins and bats that use echolocation. They can hear hundreds of thousands of hertz. But the greater wax moth, its range of hearing goes from 50,000 hertz out to 300,000 hertz, or in the radio range. Greater wax moths are hearing airport beacons. They can hear things that are very, very high pitched that our ears could never perceive. But the greater wax moth hears 50,000 to 300,000, but we hear on the other side 5 to 20,000. It means that the greater wax moth can never hear you speak. It won't hear the sounds that you're hearing. Likewise, you will never hear what the greater wax moth is hearing. And so it's already an example of something being almost alien right here on Earth. And so if we have those kinds of differences already, maybe there are aliens out there who have something like hearing, but maybe they're hearing a different range, a different frequency of vibrations. Maybe they hear things that are much lower, or things that are way, way further out in frequency. Maybe they're hearing a lot more of our radio waves, our light, as a sound. And we don't know what that would be like for their brains. So there's a lot of things that could be very, very different for aliens.
That's truly amazing, sir. So so they're having a lot of questions regarding the planets in our solar system. So into that aspect, we have created, like as we have discussed it before as well, that we have our own like a virtual simulator of solar system on which we have been working since 1 month. So we thought that if for 10 minutes we could have a ride on our solar system in which we could discuss the aspects of life on each and every planet. So,
Sure.
would you allow us to like share the virtual solar system, and then if we could go to different planets and discover things over there?
Yeah, please do.
Yeah. So we can present the solar like our spaceship. So basically, the concept is that we have a spaceship in it, and we can roam around in different planets, like experience the gravity in different planets. Like perhaps if you go on Jupiter, there's a whole lot of gravity. If you go on Moon, there's lesser gravity. So we have been working on this virtual full simulation, and we would like to know your views like how life could thrive on them. So my teammate Shashak is going to present the screen of the virtual simulation. Like yeah. So in that, so we have created around the 8 planets which are out there, and we'll be going to each and every aspect and looking forward to it. So like personally, like what's your favorite planet among all the planets in solar system?
Earth.
Earth.
Yeah, Earth is my favorite. But if I have to pick a second favorite, I'd say Venus.
Venus. Whoa. Like, so what's the reason, like, why Venus is the favorite planet?
As I mentioned earlier, I think early in the history of our solar system, Venus was very much more like the Earth. And so you might have heard before of the faint young sun hypothesis. And it's now pretty much become theory. It's pretty well accepted now that very early in a star's life, it's much dimmer. There's less light coming from that star. And so very early on, Mars was less likely to have life. Whereas Venus might have been more likely. Venus would have been warmer, closer to the sun, very similar in composition to our Earth. And
Mhm.
so I think Venus was a very likely candidate very early on. And that's part of the reason why we have to consider not just the location of a world and its size and its density, we also have to consider what's happened on that world through time. Because, like I said, Venus nowadays, the surface is not what we would consider a habitable world. However, there could be life in Venus's clouds. We really don't know yet. There's good reason to go back and search for that.
Whoa, that's truly amazing. So now, like Shashik, can you present the screen and like take us to Venus, like the planet which has been there so for so much for so time. So like it's a fact that Venus looks similar to Earth, like more than Mars. So like perhaps the like semblance, or perhaps yes, sir.
That's okay.
Yeah. So like we can begin the spaceship with the things, and then we want like to know your views upon how things are gonna happen in each and every aspect. So personally, like there have been like a lot of like I've seen one of your podcasts in which you were discussing like if we met aliens, then perhaps our like metabolism which we have acquired, like taking life from a like different organism, it can be a cruel perception on their end. So perhaps what do you think like if we meet an alien, like even the way in which we live and our perceptions of evil and good or bad will basically break perhaps if we meet an alien life?
Yeah, I mean, we've had a lot through time. We've had a lot of attempts by humans, and we still do, to understand what it means to be good and bad. And in many ways, I mean, we've had different systems of religion and spirituality and philosophy to try to help us better understand our own morality, our own ethics. But our ethics have changed through time. What we
Well,
believe to be good and bad have changed through time and will likely continue to change based on our continued knowledge of who and what we are as we learn more. And so we might meet an alien race out there
mhm.
who find us to be evil just in being what we are. They might
Well,
find us to be righteous just in being what we are. And the unfortunate thing about ethics is it's not universal, at least not yet. Our current knowledge is that it's very much based on our place and time and the knowledge that we have about ourselves. And because of this, there's a good chance that alien intelligences, if they end up thinking the same way, they might also have derived their own systems of ethics, their own systems of good and bad. Or it's entirely possible that the very concept of good and bad
mhm.
might be one that some alien races never come upon. And so it might be, rather than being immoral, some alien beings might be amoral. They might not, just like the universe. The universe has no morals. The universe doesn't think right and wrong. The universe is just the universe. Uh, and so maybe some alien races out there are very much like the Vulcans from Star Trek, and they only think through logic, and they have no connection to emotion, no connection to ideas of ethics. We just don't know yet. But again, just like with having comparative biology to help us learn more about life, if we meet intelligent aliens, they might help us learn more about philosophy, more about ourselves. And so there's many reasons that finding aliens could be very good for us.
Whoa. So like in that aspect, sir, like we can start off like what's your perception about alien life on different planets and
Mhm.
about solar system. So we'll begin from the first place, like that is the sun. So like we have thought that your area of research is perhaps the polar and the extremophiles and the lowest temperatures. So what do you think? Is there the opposite end of it as well? Like can we expect any kind of like even the hardest imagination life forms which are perhaps somewhat very close to sun or thrive on sun, like is like what is your view on that?
Yeah, so our current knowledge of life as we know it,
Hmm.
given its chemistry and the physics of life as we know it cannot survive on a star or in a star. However, like I mentioned earlier, I'm profoundly interested in trees. Trees have learned to grow higher and higher to get closer and closer to the starlight. Well, what if there's an alien being out there, or even an alien biosphere, that wanted to get even closer to their starlight? Maybe they learned how to detach from their world and go out to orbit their star. Maybe they've developed technologies, chemical rocketry or some other form of propulsion to leave their world and go to their star. One thing I love in science fiction is the idea of like biological ships. There's one episode of Star Trek: The Next Generation that I really love, where there's a being who has decided to go live by a star to live out the rest of its days and to die when that star dies. And one thing that as a young child watching this, it made me wonder is, what if there are alien beings who've chosen to go and be closer to stars to have more starlight? Of course, they'd be in more danger from solar flares and things like that. But if they've discovered biological or technological means to overcome that, then it could be quite possible that things could be very close to a star. But when we start looking at worlds, at planets, Mercury is close to our sun. But if they got much, much closer than that, it'd be highly unlikely for a world to have life on its surface, we think. At least life as we know it. One reason for that is, again, things like these solar flares, all of the energy coming from the sun, that energy breaks down with the inverse square of the distance. So the further you get from a star, not only is the star getting dimmer, but you're also not being bombarded by as much of the radiation per unit area. But places like Mercury is getting a lot more radiation than we are from our star. And if you got very, very close to a star, then you have even more risk of life being damaged or destroyed by stellar activity. And so I personally think it's unlikely, but again, anything's possible.
So like in your take, like Mercury, like if we shift our spaceship towards Mercury, so like that's a place where we cannot, like, it's not probable to have a life form over there.
Yeah, not with Mercury, at least in our solar system. Mercury is very much like our moon on the surface. So if you look at Mercury, it's very barren. There's a lot of impact cratering. So Mercury's surface over time has been bombarded not just by radiation from the sun, but also by asteroids and comets. All these rocks and materials in space have struck Mercury over and over again. And Mercury has no plate tectonics currently. It has no oceans and not really an atmosphere either. So Mercury is kind of a dead world, basically. It's still a very intriguing world. But if there were a world like Mercury that was that close to its star, but also had plate tectonics and an ocean and an atmosphere, who knows? Maybe it could have life. But again, the problem with being too close to your star is that it gets very, very hot. It's very unlikely to have a surface ocean at a place like that, especially if you have an atmosphere. That ocean will most likely boil away, and that atmosphere will likely go through a runaway greenhouse effect, just like Venus. And so we think it's unlikely to be that close to a star.
So Mercury is out of the the highly probable planets for life. So now we'll turn the spaceship towards Venus, which is the hottest planet by like the metrics and all these things, and it's also quite cloudy in nature. So it has been found that the clouds of Venus might have certain, or might like microorganisms which can thrive under these conditions. So what's your take on this? Like, that's how it can thrive in such a hot and dusty and CO2 filled planet.
Yeah. So again, early in our solar system's history, Venus was probably a lot more like the Earth.
Okay.
And then it would have been sometime in the last few hundreds of millions to billion years when it started to melt at the surface and underwent this runaway greenhouse effect. But if there was life there, maybe that life was thrust into the atmosphere. And there's a place in the atmosphere of Venus about 51 kilometers in altitude above the surface, where the surface, where the pressure of the clouds and the temperature is actually very close to what we have here at sea level on Earth. And so it's actually very clement for life as we know it. And so maybe there's a region in the Venusian atmosphere where there could be microbes that are atmosphere thriving beings that are living up there. And we just don't know yet. We haven't had any sign of them yet. However, you might have heard very recently of this potential detection of the molecule phosphine in the upper atmosphere of Venus. Now, there's a lot of debate, a lot of rigorous and active debate right now as to whether or not that phosphine detection is real, and if it is, what it means. But currently on Earth, the only time we find phosphine naturally on Earth is when it's produced by organisms, by life.
Okay.
So the Venusian phosphine, if it is there, and again, that's still debated, if there is phosphine there, that could actually be a sign of the activity of life in Venus's atmosphere. And so
Okay.
I personally, I want to see more missions to Venus. Oftentimes we see missions that are proposed for Venus and for Mars, and we end up always seeing them go to Mars. But I'd love to see some more Venus missions in the near future. We have so much more to explore there in the atmosphere, on the surface, and in orbit of that world.
Oh. So like Venus is the place which has been like Earth, and it's a wonderful like area where as like alien life could thrive. So now like we come to the our home itself. So like we all know that life does exist on this planet. There are no question on it. So what's your favorite organism? So like what's the like organism which you truly like on Earth? Like obviously apart from humans, but like which has like gives you a fascination. Like
That's a great question. There's so many life in the deep oceans, things like the anglerfish and some of these bioluminescent organisms. They kind of are mind blowing to me. I really love hummingbirds.
okay.
Hummingbirds are the smallest birds on the planet, and they also have outrageous metabolisms.
Hmm.
They require so many calories given their body weight that the amount of calories a human would need to eat in a day to stay alive the way a hummingbird does is mind shattering. It's just so much energy that they need to flap their wings that hard. And there are plenty of organisms around our planet. The mantis shrimp is a cool one. I'm a scuba diver as well, and so I kind of have an affinity for ocean dwelling beings. But as I mentioned, I've also done research on polar environments.
Hmm.
And my research in the high Arctic in Canada many years ago, I had a really cool opportunity to track down the nest of a snowy owl. And owls and other birds of prey are just remarkable organisms to me. And so I think I would have a very hard time finding a favorite organism on Earth. I do think humans, sometimes we are too harsh on ourselves. We have altered our environment. We have contaminated ecological systems. We have caused great changes to our world, but we've also done incredible things. We've moved mountains to learn more about our place in the cosmos. And so I think sometimes we don't need to be as hard on ourselves. We have a lot of reason to have hope for our future and the good things that we can do.
That's quite hopeful, sir. Like that's similar to the speech, like you said that humans have moved mountains. So like that's a famous speech, like we shall go to the moon. So like now, like what do you think? Like is like there have been a lot of hype about moon, perhaps in the previous decades. But now, like what's the status? Like are scientists even looking moon with that much level of curiosity, or it's still mysterious? And now things have got sorted.
Oh, there's so much more to learn about our moon. Our moon is very unique in our solar system. So Venus doesn't have any moons. Mercury doesn't have any moons. Mars has two very small moons, Phobos and Deimos,
Yeah,
and they're very much small asteroids that got caught
yeah.
in the gravity of Mars. But our moon, likely, we think, formed from a large impact of a world maybe the size of Mars that crashed into the Earth long ago, and parts of the Earth, parts of that world came together to form our moon. And so our moon has helped us to stabilize what's called the obliquity. It's the angle at which our planet leans. Um, and the moon might be one of the things that allows life to have sustained itself here for so long. We just don't know yet. And I want to go back to the moon. I want to see humans, like in this image here. I want to see us have bases on the moon. I think we should go there. I think we should explore there. And I think we should do it internationally. I think we should do it as a global people, not as a single nation, not as a single government or agency. I think we should do it together and do our best to try to not take our problems here on Earth along with us. That's a big ask. It's a lot to ask of people to leave behind our problems. But if we do go to the moon and beyond, we need to start thinking more consciously about who and what we are and how we can care for each other and work together through these things. When it comes to potential for alien life, I don't personally think the moon was ever a habitable environment for life. Now, that's life as we know it. However, one really cool thing about our moon, so we have these processes of planetary impacts. So not only do we have grains of ice and dust coming through our atmosphere making meteors or shooting stars, but sometimes we have these things that are big enough that they actually hit the surface. We have meteorites, like in my collections. We also have very large impacts, like the one that caused the final demise of the dinosaurs at the end of the Cretaceous. Some of these impacts have so much energy that they actually will take some of the rock during the impact process when it's making that big crater. Some of the rock will get launched back into space. And so we have very good reason to suspect that there could be rocks on the moon that came from Earth long ago. And it could even be possible that some of the earliest types of life on Earth were trapped inside of some of those rocks and are right now sitting on the moon waiting for us to go there and explore and find them. And if we find those rocks, we might actually be able to learn more about the earliest life on Earth than we ever have before. So that by itself is a great reason to go. Of course, there's many others, not just the joy of exploration. There's also potential for developing lunar resources. And then also many of us would love to see large observatories, large telescopes on the far side of the moon that could allow us to observe the universe from a stable lunar base.
Yep. Yep. Like even in this simulation, we have created an observatory, like based on that thing itself. So we have tried to simulate the whole sky. So in your aspect, like if you have the choice, that if you want to predict, then perhaps moon is the place where humans will have the first like settlement, perhaps outside of the Earth. Like what? Like it can we say it that way?
I think so. I very much want to see humans go to Mars,
Hmm.
but the moon is close.
Hmm.
It's still protected by the Earth's magnetic field, even though the moon is actually quite far away from the Earth. If you actually look at the distance of the moon from the Earth, it's something like 30 radii away. And so it's actually a good distance away, but it's actually still protected by our Earth magnetic field. And
Whoa.
so sending humans in the Apollo missions to the moon, they never actually had to travel too far away from the Earth where the radiation gets even worse.
Hmm.
And so to get to Mars, we're going to have to think a lot more about how we mitigate the radiation and how we handle those long duration missions to Mars. I think we're quite prepared for it, but I think the moon is more likely to happen first.
Okay. So, like you said that as moon is protected by the magnetic field of Earth, so what has happened to Mars? Like it's been rare and known by a lot of people that Mars magnetic fields have got slow, like kind of weakened over the time, of they are not that strong. So, what happened over there? That's something which was so much probable, and now even we look Mars at the as a site of life. So, what happened? What like which caused such kind of thing?
Yeah, we're still learning about what is really required for magnetic fields to persist for long periods of time. And maybe it is having a large moon is helpful. But with our Earth, our Earth is slowly cooling. All worlds, when they first form, there's a lot of energy that comes from that formation process. As all the rocks and materials are melting together, there's a lot of heat produced. But scientists learned long ago there actually wouldn't be enough heat produced from just the accumulation of material to make a world to allow our Earth to be as warm as it is now. And so they realized there had to be another source of energy. And it turns out that radioactive materials, things like uranium and thorium and potassium
Mhm.
inside of our world in its core have helped to keep our world warm through time. So it's not just the sunlight that matters, the starlight, but it's also the size of the world and how much of this radioactive material it has. And so our magnetic field is formed from the movement of our outer core. There's this liquid part of our planet's core, and it's moving. And as it's moving, it's creating that magnetic field like a big bar magnet out around our planet. And it's very active. But Mars appears to have cooled. And so Mars doesn't have that nice liquid metal part of its core to allow it to have a sustained magnetic field like we do. And again, maybe a moon could have helped stabilize that. So Mars, I mentioned our moon stabilizes our obliquity. Mars moves back and forth really quickly in its obliquity. That might be a part of the process that's important. But it's also Mars's size. Mars is about a third the size of the Earth. It's actually quite small in comparison. And so Mars is a small world. Maybe it had oceans long ago. We definitely know it had standing liquid water at the surface. We don't know how much. I mean, we don't know if there were seas and oceans, but it's possible early on in Mars's history when it was still very warm. But Mars has cooled through time. It's lost its magnetic field, and then its material has slowly been stripped away by the bombardment of solar wind. All these particles and energy from the sun have been slowly stripping away Mars's atmosphere, removing its water through time. And then a lot of that water, as it cooled, got bound up in permafrost in the subsurface. And so Mars doesn't actually have a magnetic field being produced from that magnet inside anymore like we do. Mars now, it does have some magnetism that's been trapped in the rocks. But Mars by itself, though, then does not have this nice stability like our Earth does, to have a magnetic field protecting it from the bombardment of radiation. And so when we went to Mars with the Curiosity rover, one of the coolest instruments on board, in my opinion, was the radiation assessment detector. This was the only instrument they had turned on as soon as the spacecraft left the Earth. It recorded the environment of radiation the whole way to Mars, and has since been reading all the radiation at the Martian surface. And so we know from that now that there's actually even more radiation on the surface of Mars and on the way to Mars than we thought before. And so sending humans there will be quite dangerous. Not impossible, but dangerous. And so we'll have to find ways to mitigate that radiation by using shielding of different forms, finding ways to stabilize on the surface our habitats, perhaps by burying them in the regolith or putting them inside of lava tubes. But again, I do want to see humans go to Mars. I think it's a really cool planet. It's one that we really should go explore.
Yep. So, like taking that into consideration, so now like we have the two famous giant planets of the solar system. So, like these are the ones with the largest magnetic field, and like recently we had the Saturn Jupiter conjunction as well. So, like, what is the like these planets are basically quite stormy. They have a lot of clouds. So, I've read a book of Stephen Hawking in which he predicted that perhaps we can have a life forms which we can take like lightning, because there's a lot of lightning happening in Jupiter. So perhaps there can be certain life forms which take up that energy to like survive and thrive. So what's your take on these two huge like giants of our solar system?
Yeah, so for Jupiter, so life as we know it doesn't appear to be in Jupiter's atmosphere, doesn't appear to be able to survive Jupiter's atmosphere. But the very first Cosmos series with Carl Sagan famously had a very cool segment where Carl Sagan basically, hypothesized what life in a gas giant might be like. He envisioned potential giant bags of gas, kind of like a blowfish here on Earth, how it fills up with fluid. Maybe there's giant bags full of gas that have learned how to float in the atmospheres of these gas giants. Maybe there are other organisms that have converged on that evolutionary idea of flight. Maybe they've developed wings and gliding mechanisms. We just don't know. But it does seem possible. The issue is, how does life then originate in these places? Would that life had to have come from somewhere else and then somehow crash into the atmosphere of a gas giant to start thriving there? And so even though no one's currently like seriously looking for life in the atmospheres of Jupiter and Saturn, it still does seem possible there could be alien worlds out there that are gas giants that could have some kinds of organisms in their atmospheres. However, I think, go ahead.
Yes, but like previously you said about Enceladus and Europa. So like them being not that suitable places for life, but Enceladus, which is a satellite of Saturn, and Europa, a satellite of Jupiter. What's like how these satellites are so much useful and can be a good place for life to thrive.
Absolutely. So those are the worlds that a lot of us are getting very intrigued by right now, these ocean worlds. And so we know of something like 79 moons around Jupiter right now. Saturn now has 90 some. And I just saw a paper that came out that predicted there could be as much as 1,000 moons around Jupiter with these much smaller bodies than what we discovered so far, that we need to go back and look for them. And so we're discovering these giant worlds, they just attract rocks to them. And a lot of them appear to be captured asteroids, captured comets, but they also have some rather large moons. The largest moon in the solar system is around Jupiter. It's called Ganymede. But we have other moons like Europa, moons that appear to have subsurface oceans. Europa is one that I find especially intriguing. It's very close to the size of our moon. And it has a surface of icy crust. And we can see where that ice has cracked and shifted, just like ice flows here on Earth. And the physics of it shows us that surface is cracking the way it's orbiting around Jupiter. That helps to support the idea of there being an ocean down there. But also we had a mission called Galileo to Jupiter that showed us, based on the magnetic field around Europa, that there's very likely an ocean down there. And our current data from our missions and telescopes, from modeling, suggests that the surface crust of Europa might be something like 10 kilometers or so in thickness. It could be more thick, it could be less, but I think 10 kilometers is a rough average right now of the ideas. And then the ocean, it could be as much as 100 kilometers in depth. For those watching, the oceans on our planet are nowhere close to that. That's extremely deep. If there's 100 kilometers of ocean down below the surface of Europa, that means there's more water, more liquid water in Europa's ocean than there is in all of the oceans of Earth. And it also means that if there's potential for hydrothermal activity, for hot water being recycled in the bottom of the ocean of Europa, that could be an oasis for life to not only begin, but then to evolve through time. If life can actually start inside of oceans, then it seems like it's very possible for life to be in Europa. And then if we look at Enceladus, which is around Saturn, Enceladus is a much, much smaller moon. But with Enceladus, we've actually flown by Enceladus with the Cassini spacecraft and have flown through plumes of liquid water erupting from Enceladus. And based on the chemistry of that water, we have very good reason to think there's hydrothermal activity in the ocean of Enceladus. And so Europa and Enceladus, they give us very good examples of places we should go and look for life. Because maybe life on worlds like Earth isn't common. Maybe life in ocean worlds like Europa and Enceladus is actually the far more common form of life in our universe.
Whoa, whoa. So like it's so much amazing to listen about these wonderful satellites. And I've seen a photo of it, like I think Europa, in which there were blooms of water coming outside, like through the planet. So, and perhaps it said that there were certain elements of carbon or fragments which were found in that fountain of water which was coming outside. So, like that, what's your favorite site of like Saturn or Jupiter which you have ever seen? Like my personal favorite was the one in which water was coming outside. Perhaps Juno and Cassini and the Huygens probe which was sent out to Titan. Like, what's your favorite like picture or video which you have ever seen in these planets?
Those are really great questions because there's so many cool worlds. So Io or Io is another moon of Jupiter, and it's the most volcanically active place in our solar system. And so looking at it as a planetary scientist, not as an astrobiologist, I find a world like Io to be very intriguing. When we see a picture of Io in visible color, you see the marks of eruptions from volcanoes, from the red and the yellow and greens of sulfur being blown into the surface or blown off of the surface. I find that very intriguing. The highest resolution image we have of Europa, to me, is a very stunning image. Now, that image isn't going to last forever. So as of right now, it's from the Galileo spacecraft. It's the closest that it got to Europa. And when you look at this image, you can see these large spikes of ice, these scarps of ice, cliffs. It makes it look very hard to land on Europa, but we haven't actually mapped the surface of Europa very well. So with the next big mission to Europa called Europa Clipper, we're going to map the surface in high resolution all over. We're going to get much better data. We're going to learn if there actually could be plumes at Europa. We've never actually seen plumes at Europa. It's only been hypothesized. But we have data from the Hubble Space Telescope where we see signs of what could be hydrogen and hydroxyl from water that appear to be plumes coming down from the southern region of Europa. And so maybe there are plumes there. One of the instruments on board Europa Clipper is actually being built so that, at least in part, it could be used to fly through plumes and to study them for potential chemistry and biology. And so Clipper is going to be a very cool mission. The European Space Agency has a mission called JUICE, or Jupiter Icy Moon Explorer, that's also going to be going out. It's going to look at Callisto and Ganymede, but JUICE will also be looking at Europa. So definitely a world worth exploring more. But the world that you mentioned, that we actually have a picture of the plumes coming out, that world is Enceladus.
Yeah, Enceladus.
Yeah, and with that world, we've flown through the plumes, we've sampled them, and there are really stunning images. I think my favorite image from Cassini of Enceladus is an image looking with the sun behind. So all you're seeing is a dark silhouette of Enceladus. And then at the very southern region, in this region we call the Tiger Stripes, you can see the plumes of fluid coming out of Enceladus with the sunlight behind, making them light up. That's the prettiest picture of Enceladus for sure. Another very cool image that's worth looking at, there's a mixed infrared ultraviolet image of Titan, where you can really see Titan's atmosphere. Titan has a very thick atmosphere. It's also a very large moon, and it's one that we're also exploring for astrobiology.
Whoa, that's truly amazing, sir. Like, and that's thanks for the correction. Like, it was Enceladus. I thought it like Europa and Enceladus are quite similar, but still. So now we can talk about the other two planets which are left, which are the icy giants. So Neptune and Uranus. Like, what's your take about them? Like, how do you see at them?
My current take is that we need to go there. So for everyone watching, I'll put this question out and see if anyone knows.
Yeah.
Does anyone in your audience know how many spacecraft have we sent to Uranus and Neptune, or have we flown past Uranus and Neptune?
So yeah, that's the question. People in the chat, please tell your answers. That how many actually space bodies, like objects or the instruments or probes, have been sent to Uranus or Uranus or Neptune? So that's the question. Uranus and Neptune तक कौन सी चीजें पहुंच चुकी हैं? Like कौन से ऐसे थे missions जो पहुंचे? And please tell your answers in the chat. And perhaps you can also watch it live, like in your screen.
Yep, I'm watching right now. I see the right answer coming in a few times already. And so I see a few. I see a zero. Fortunately, it hasn't been zero. I see a guess of 189. Definitely not 189. But I see the right answer several times. I see Nishi Shukla, Penguin, Artha Shukla. Yeah, several have gotten it right now. We've only ever had one mission. So Voyager 2. Yeah. The Voyager 2 spacecraft is the only mission we've ever sent to Uranus and Neptune, and it didn't even stop. It just flew right by them.
Yeah.
So the only thing that has ever gone out there is one mission. Back in the 1990s, it would have been in early 90s, that Voyager 2 flew past Uranus and then Neptune. And so we need more missions. There are likely very good candidates for icy worlds. We know of Triton. Triton is a very beautiful moon, and it's worth exploring. We know of a few others, but there's probably many, many moons of Uranus and Neptune that we've never discovered yet, because not only are they even harder to find moons around, being that much further from our sun, we've only had one spacecraft go there so far, fly by. And so I personally think that we need at least one large mission dedicated to Uranus and one large mission dedicated to Neptune. We need to go back and study them more, to understand them as planets, to look for their moons, to study their moons. There's so much of our local family of worlds that we know so little about because we haven't studied them in detail. And there's good reason to think that they might be really important in studying exoplanets. So there might be many, many, many more worlds like Neptune and Uranus than there are Jupiter and Saturn. And we won't know that until we actually start exploring and learning more about how to look for them. There's more that we're learning right now in exoplanets and trying to find these extrasolar worlds around these other stars. And there's a good reason to think that many of them are actually more like the size of Neptune than we thought before. And so we need to get back to Uranus. We need to get back to Neptune and do more research there. I'm very hopeful for future missions to see what we can learn about those worlds.
Wow, that's truly amazing. Like these are the farthest planets, and like one of the planets which have not been visited by humans a lot. So, like a mission to them would like unravel a lot of more mysteries and like secrets which are hidden in the deep blue skies of them. So like now comes the favorite time of the audience, like where it's the question answer time, and it's the fun part because like most of the audiences which we have, it's basically quizzing and sci-fi geeks. So all these little kids, they are like very much into space, black hole, and all these things, and like they ask so many questions. Like you must have even noticed, like throughout the session, the chat was filled with a lot of questions. Sir, please answer me. Sir, please answer me. So now it's the favorite time where we can like end the spaceship mission now, and now we can directly head on towards the question answers. So the like as promised before the session, we have taken you to a virtual ride of the whole solar system with Graham sir, and now we are coming back. Now we can end the spaceship ride and directly get into the question answer round. Yep. So Graham sir, like, would you like to take questions directly from the chat?
Sure.
Yep.
So I have several about aliens, what they look like. Ooh, here's a fun one from Somya Shital. Why did humans have not tried to land on the moon after the year 1969? And it's a great question. And we have landed after 1969. The last mission on the moon was 1972. So over a very short period, we had Apollo 11 through Apollo 17 go to the moon. Only the last one actually had a geologist on board.
Whoa.
So Apollo 11, the whole way up, it was all military. They were pilots and test pilots, mostly military background. And then on Apollo 17, we finally had Harrison Jack Schmitt go to the moon, and the rocks that he collected might have been arguably the best rocks because he knew what he was looking for as a geologist to find really cool rocks to bring back to Earth. But your question, Somya, why haven't we gone back? And there are so many answers to that. Part of it is politics. The politics of the space race, for one. So a lot of Americans got behind the idea of sending astronauts to the moon, not because of exploration, not because of what we gain from it as a species, but because of the Cold War and the fact that the US and the USSR were in a war at that point in time, in a Cold War that lasted until the 1990s. And because of that Cold War, it really was just about saying we're first, and then that was it. And so a lot of politicians in the United States of America stopped having interest. You have to remember that for its time, and even now really, the Apollo program was extremely expensive. The Saturn V rockets were very expensive rockets. The Apollo program required a lot of resources to develop and launch. We know now that we could do it better, and I think we will very soon. We have private companies around the world getting interested in medium lift and heavy lift rockets. Of SpaceX, I'm sure. There are others that are getting interested in creating better and better rockets to get more and more spacecraft out there. I think we're going to see more lunar programs very soon in our history. But we also have this issue of explaining to the public, explaining to people around the world why we should work together to go explore space, why we should work together to go explore the moon and Mars and other worlds. And really, when we can actually do these things together, we can fund them and support them so much better, and we can put more minds toward it from around the world with different perspectives, and we need more of that. So the infighting, the Cold War, space races, those things give us very quick results that very quickly then fade. Because when all you're looking for is to say, I did it, then that doesn't really help you succeed further on in life. The same thing for your own education. When you're learning, it's not just about completing a degree or earning the certificate. What's important is what you've actually learned about yourself and about the world along the way. And when we have things like a space race, all we're doing is aiming for the end post, the goal, and we're not thinking any further down the road. And so to fix that kind of thinking, we need to think more long-term as a species. And that applies to more than just exploring the moon. That applies to working together to solve climate change and other issues on our world. It applies to how we handle the upcoming revolution in artificial intelligence and these things. We need to have long-term thinking as a species.
Exactly. So like with respect to that, like there are a lot of mission like questions about those future missions, which like some people are asking, is there any mission to Sun or some Mercury? Like which mission is in particular, like do you like hope for the best? Like which mission is out there which excites you the most, and you are waiting for it?
Absolutely. The past, so I'll give you three: the past, present, and future.
Okay.
So the past mission that still to this day inspires me the most is Voyager 1. The Voyager spacecraft, they were examples of us thinking long term. We used them to do what was called the Grand Tour because we had a planetary alignment of all of the outer worlds of our solar system. And we knew if we launched spacecraft right at that moment, we actually could explore those outer worlds. Again, Voyager 2 is the only one that went past Uranus and Neptune. But Voyager 1 also turned around about 6 billion miles away and took that famous picture called the pale blue dot, looking back at our Earth. It's the most distant image of the Earth we have to this day. And it's a moving image. And so Voyager 1 for the past is my favorite. Of current missions that are out there right now, I'm very much looking forward to the Perseverance rover, but even more so personally for the Ingenuity, the drone. So those who know me might know that I helped to staff and run a undergraduate student engineering competition called the University Rover Challenge. We have it every year. We have teams from India and Bangladesh and Egypt and Canada and the US and the UK, all over the world competing. And a small group of those teams who are most successful in the competition, we invite them to come to the US, to Utah, to the Mars Desert Research Station to compete. And one very cool thing I've seen over the years, there have been teams that have built drones to launch off of their rovers to do surveillance and to help them do science. And so I'm very excited to see the same thing now on Mars, Ingenuity. Now, Ingenuity is just a test. So don't expect, it could fail. We don't know exactly what to expect. There's not a lot of instruments on board. The primary goal of Ingenuity is just to launch and just to show that we can do this, that we can fly a little drone around Mars. But if that works, then I have a feeling that upcoming missions will all have maybe not even just one drone, maybe many drones that can launch off their back and do a bunch of really cool science. So I'm very much looking forward to Perseverance and to Ingenuity. That'll be very cool. And then for future missions, one that's currently planned that I think is going to be really exciting. Like I mentioned, I love Europa, so Europa Clippers, very near and dear to my heart, but I'm also really excited about the Dragonfly mission. If you haven't heard of Dragonfly, it's going to be a craft about the size of a small car, and it's going to go to Titan, that moon around Saturn with a very thick atmosphere. It's going to fly around Titan. It actually has 8 propellers. And so this thing is about the size of a car, but it's also a drone, and it's going to fly through Titan's atmosphere and do a bunch of really cool science. And even though the surface of Titan is so very cold that life as we know it can't thrive there, there's still so much to learn about the chemistry of Titan's surface and its atmosphere, the organic materials around it, and to see if there is an ocean on Titan, and there could be, maybe there's some connection from the organic gunk to the ocean, and we could actually find potential signs of life from that ocean in the near surface. And so I'm very excited for Dragonfly.
Whoa, that's truly amazing, sir. So now, like, I think a lot of questions have come up. Okay, like, would you like to see at the chat, sir, and pick up your like favorite question among it? Like, a lot of people are asking the questions.
Ooh, this is an interesting question from Sage Al Suri. In our life, what are we going to see in the next 50 years? Any new discoveries? And that's a big question to ask. And thank you very much for that, Sajal. Um, the big answer that almost all of us have to say is we don't know, as always. And there's one interesting thing that happens, and I had a friend tell me about this years ago. She's a computer scientist, and she's thought a lot about futurism, about how we can predict the future based on current technologies and science and culture and politics and things like this. And one thing she said is that many of us, at least those of us who study science and study engineering and study technology, we are actually pretty good at guessing how things are going to be up to about 5 years out. And right now, I could probably guess pretty well the next 5 years of science and technology and some of the things we might discover. But then there's this hazy zone from like 5 to like 20 years where you can guess some of the general things that will happen, but it's very unlikely you're going to actually get it right. Things are going to change very quickly. So if you go back 20 years from now in the year 2000, there's a lot of things right now that we're doing that people weren't expecting. People weren't expecting us to be online like this, communicating around the world in these kinds of numbers. This year, I've spoken to about 50,000 people this year online, by webinars, and people from around the world, from many nations. And in 2000, we didn't see that coming in the scale that it is right now already. There's other things going on right now in computing, in fusion energy experiments, and all kinds of things that we just weren't prepared for at all. And again, exoplanets. Back in 1994, when I was a kid, I would not have guessed by right now that we'd know of over 4,000 planets. And so if you ask me to start looking out 50 years, it gets even harder. But here are a few of the things that I think are going to happen in the next 50 years. First off, I think within 50 years, we definitely will have people on the moon, and we'll most likely have people on Mars. 50 years is a very long time. We have enough people right now in the world, not just from government agencies, but also private companies who want to get people to Mars. And so within 50 years, I think we'll have humans exploring the moon, exploring Mars, and maybe even beginning to prepare to send humans further. In the next 50 years, so I mentioned earlier this idea of artificial intelligence. We're only right now at the cusp of really starting to understand machine learning, artificial intelligence, and we are using artificial intelligence already in our coding and in how we try to solve problems and try to understand large data sets and things like this. But I think in 50 years is right around the time that we're going to be at this very crucial point in human history where we really, really, really have to be prepared for what happens when artificial intelligence becomes a super intelligent artificial intelligence. And we're not very far away from that. So you might have heard of Neuralink. Right now, we're trying to map out how the mind works and to use the mind to control computer systems. And that's only just beginning. But in 50 years, I think we'll very much be at that point. And so again, I'm a huge fan of science fiction. There are other ideas. There's a great show I'm watching right now called Altered Carbon. And there's others out there that kind of look at what happens when we humans start merging more into our machines and start altering our biology even more. And I think in 50 years, we're going to get close to that. By about 50 years from now, we should have the medical technology to allow humans to live well over 100 years just through using science and technology. However, another thing that I really think is going to happen in the next few decades, and I'm hoping that 50 years is enough time for this to happen, I think the whole idea of United Nations, having a global body of government to work together, it's a good idea, but the United Nations hasn't really functioned, I think, the way it could. I think that we need a better vision of being Earthlings, and I think 50 years is right around the right amount of time it's going to take for us to start realizing that. I think we're still going to have wars and infighting and a lot of problems, but I think in about 50 years, we'll start realizing that we need something that's better than what the UN is and start building it to help be prepared for how do we govern ourselves, or how do we govern when we go to the moon? How do we govern when we go to Mars? And these are big questions. And then when it comes to alien life, and that's a fun one. So a few years ago, a woman named Ellen Stofan, she was the chief scientist of NASA at the time. Now she's the director of the National Air and Space Museum here in the US. She predicted that within 20 years, we would have definitive signs of alien life. I think that's a little too soon, but I think within 50 years is a pretty good guess. So I would personally say that if there is alien life out there, if we're not alone in the cosmos and life is at least somewhat common, then by 50 years from now, we're going to have several more generations of space telescopes. We're going to have more time to listen in radio and infrared and other spectra to try to see if there are signs of alien life out there. And again, we know of over 4,000 exoplanets right now. Within 50 years, that number will probably well more than double. And so I think it's very likely that we'll find signs of alien life out there in the next 50 years, if it is out there.
And with respect to that, you are like for yours, like your personal interest is on Venus and exoplanets, which are perhaps outside the solar system.
Absolutely, yeah. There's a lot of cool places to look for potential for life in our solar system and beyond.
Yep. So what do you think? Like, which question would you take next?
So I see one here from Arvind Kumar. Mm-hmm. Arvind asks, can we found another planet where we can settle our life? And that's a big question. And so we talked already about the moon and Mars a little bit. But one thing that you'll see a lot in like science fiction films, you'll see humans going out to worlds around other stars and creating human colonies and bases. That might happen at some point in our future. Now, it might be that we'll be more of a machine, a post-biological being by the time we start doing that. But the reason it's really, really hard to do that is the other stars are very far away. Even the closest star, Proxima Centauri, is 4.2 light years away. That's 4.2 years it takes light, traveling very quickly to get here. Our rockets, our current fastest spacecraft, Voyager 1 and New Horizons, they would take a much, much longer time, tens of thousands of years to travel that distance. So if we're going to send humans in our current form to those worlds or other stars, we either have to have generational ships where humans can live and die and have children and have colonies of people on the ship for many tens of thousands of years or millions of years, or we need to figure out hypersleep, this idea of putting a human being to sleep for a very long period of time, or we're going to have to wait until we evolve and become machines, become post-biological beings. That could be through genetic engineering or through downloading our brains into computers. There's a lot of things that could happen there, but we're just not there yet as a species. And so I think right now the important part is more philosophical. I love exploration. I love the science and technology we're developing, but we're not prepared right now for some of these potential changes. And I think the best way to get there is to start having conversations, to start studying philosophy, to start actually thinking more about these bigger ideas of what it means to be alive. What is life? What is consciousness? And should we go out into the universe to explore? Do we have a biological reason to do this? Maybe we do. If we are the only life in the universe, then it almost feels like we're required by the universe to go out and explore and settle other worlds. But even if we're not alone, if there is alien life out there, maybe the only way that we'll ever get a chance to say hi and go talk to them is by going there ourselves. And so there's a lot of things that we need to think about deeply as a species when it comes to exploring our universe and our place in it.
Yep. So adding to that point, like we as well, like we have been working at that specific element of curiosity and exploration. So what do you think, like how much curiosity plays the role in the whole development of us as a species, and how it natures and shapes us, and how important do you think, like this chat is getting filled with questions throughout, and people are asking questions. So what, like, is curiosity quite elemental to our species? Are we by birth curious, and is asking questions a gate step of exploration and something?
Yeah, I think curiosity is the natural evolution of a species to develop civilization. Okay. So what took us from what we were tens of thousands of years ago to where we are now was being curious. We had this need for security. We had this compulsion to work together in packs, to hunt and to provide shelter and to protect ourselves.
Mm-hmm.
But I think through that process of finding security, of overcoming our fears together, that process of bringing us together for security also led us to start speaking to each other. Mm-hmm. And by communicating an idea, it probably was not too complicated originally to say, like, I have a rock, I can use this rock as a tool, and to show someone else that. But maybe then somewhere along the way in the mind, it starts to click. Is there a better rock? Mm-hmm. And you start asking questions. The mind starts to process questions. And it's our curiosity that allowed us to start looking for that better rock, looking for the better stick, looking for better building materials, better ways to make fire, better animals to eat, better plants to grow, better berries and nuts to harvest. And it was our curiosity. It was our curiosity that drove us to start wondering, when looking at the skies in the night above us, what is that? Is there something else? I think curiosity drove us to our mythologies, to our stories, where we very much placed ourselves in the earth and in the heavens. We started creating stories that gave us a special place, underground, in the underworld, and here on earth. It connected us to the environment, to nature around us. We gave ourselves these ideas that connected us to the heavens above, to the movements of the stars and the planets. But that same curiosity eventually led us to science and mathematics. It allowed us to ask, if we have these seasons occurring, can we actually predict the seasons? Can we predict, based on the movements of the sun and the moon and the stars, when to grow our crops? Could we build walls? Can we build buildings? Can we build better features? And it was all based on curiosity. And that curiosity led us further and further, and to the point where we are now. All of us now live in a place in our world where humans have stepped foot on the moon. We have sent spacecraft to other planets. We now have several spacecraft that have left the orbits, the realm of our inner solar system, that are now traveling in interstellar space. We've now had almost 600 people, very close to 600 people, have left the planet and have looked back at our Earth from above and have had that overview effect, that psychological shift in the realization that our planet is just this rocky ball hanging in the cosmic void. And all of the life that we know came from this one little world, this one little place in the cosmos. And it's our curiosity that continues driving us forward to ask these bigger questions too. Again, what is life? What is consciousness? Can we become machines? Can we extend our lives? Is there other life out there? That's all based on the process of asking questions, of being curious. And if our species ever lost that feature, I don't think we'd be human anymore. I think curiousness, to explore, is to be human. And this curiosity is what drives us to explore.
Yeah. Like, to be curious is to be human. Like, that's a wonderful statement for us. Like, so, like, in my association with you, like, I have been mailing you regarding my work and everything, sir. So what's your insight in regard to that? Like, whatever things which we have been building since our first year of college, and I have been, like, updating you with all the developments which we have been doing through AR or game-based things. What's your insight, like, take on whatever things at the people who at Kalam Labs are doing?
Yeah. So you and I have been discussing this for some time now.
Yeah.
And I love the idea of using augmented reality and virtual reality to improve our educational experiences. We can use these tools, these new technologies, to make education better than it has been before, for ways that make it tactile, that you can actually engage. Augmented reality allows you to engage in your local environment with a virtual environment, which is very cool. And it allows our minds to explore in ways that are a little difficult sometimes to explore just by reading or just by writing. And so there are things we can do with augmented reality and virtual reality that can allow us to actually think a little bit deeper about what we are. So I'm very much into meditation. I teach meditation, and I've been meditating for a very long time in my personal practice. And even though I think there's a great value to meditating just by yourself as a human, just sitting or laying down or however you choose to do it, there's also ways to use AR and use VR to meditate on the cosmos and our place in it. And if you're using an augmented reality app to look at exoplanets, to look at the sun, to look at the worlds of our solar system, that process in and of itself is a meditation for you. You can think then on the grander scale about the world around you, about the cosmos around you. And so those things are all really groovy, as I would say.
Yep. So like now, so like all the people who have been watching us since like 1.5 hours, there've been a lot of people out there. So what's like there has been question like if we want to pursue like the mysteries of alien life, if you want to pursue such kind of a thing, so what's the action plan? Like what they should do like at their age when they're like around 10 to 15-year-old kids like moving around on the internet searching on Google. So, what do you think they should do at this point of time in order to nurture the curiosity as well as to gain the knowledge in a good and presentable way?
Absolutely. First off, I do have to say I'm very excited for the future of India in astrobiology. I speak to students from India all the time about astrobiology. My friend Siddharth Pandey now is the director of the Amity Center for Excellence in Astrobiology. My organization, Blue Marble Space Institute of Science, we helped through Modern College in Pune some years ago to organize the very first certificate course in astrobiology in India. And right now, for the young people watching right now, you might feel like there aren't opportunities for you. And one thing I have to say, that there's two things you can do. One is wait. Even though ISRO doesn't have an astrobiology program right now, I personally think it will. In the next 5 to 10 years, I think there's enough curiosity and interest in astrobiology in India for ISRO to actually fund and develop its own astrobiology center or program. The other thing is to make those opportunities happen for yourself. If you're interested in astrobiology, learn about it. Find your networks, find groups like Kalam Labs and others who are interested in these things and connect, network together, and start building these things yourselves. There's no reason, there's nothing stopping you from building your own astrobiology network, your own astrobiology center. You can do that. Now, when it comes to actually becoming involved in astrobiology, in the science, the engineering, the philosophy, if you want a career in astrobiology, a few things I recommend. First is be a generalist and a specialist. And so what I mean by that, all of us who are scientists or engineers or philosophers who are working in astrobiology, we all have a specialty. We all have some specific area of research that got us really intrigued and took us to where we are. So for me, my interest was how life interacts with the environment and how we can use that to look for life elsewhere. And that led me through my degrees in biology and chemistry and studying astrophysics and geology. But a lot of astrobiologists, they will only study biology, or they will only study geology, or only study astronomy. They have a specialty. But the cool thing about astrobiology is that it brings us together to speak the languages of multiple disciplines of science, of multiple realms of engineering, of the philosophy of science, the philosophy of mind, of the history of science. And to speak these different languages, to understand the vernacular and the ideas coming from all these realms, you have to be a generalist. And so if you're interested in astrobiology, read a book about biology, learn a little bit about chemistry, study some mathematics, but also study philosophy, read about poetry, about what it means to be human. There's so many things that come together to culminate into this realm of astrobiology. Because when it comes down to it, astrobiology is the quest to understand life, to understand what it is to be life. And so that's everything. That's philosophy and spirituality. It's science and engineering and poetry and art and music. And so be a generalist. Find interest in all these different things, these passions you have in the world, and follow them. But remember that if you do want to be a scientist doing research in astrobiology, you do have to have one single thing that you go the deepest on. And that could be anything that really intrigues you, but you have to have one specialty that takes you very deep. The other thing, I mentioned before, finding a network. There are networks around the world you can get involved with. Reach out to people. Find astrobiologists who are doing work that excites you and reach out to them. I mentioned my friend Siddharth Pandey at Amity University. He's doing a lot of wonderful things right now with building up an astrobiology program there. There are other groups and people around India who are interested, but also around the world, there are astrobiology networks and conferences and meetings. And because of this pandemic, as tragic as it has been, as hard as it has been for all of us, it's also bringing so many more of our voices online. And it's making it possible for all of you to connect with meetings and conferences on astrobiology in the US and Australia and in Chile and all over the world, in the UK and places all over Europe. There's so many places now where people are getting interested. And because of our online interactions now, it's making it more and more possible to get involved. If you're on social media, there's a bunch of us who are sharing not just our astrobiology, our science, and our interests on social media, but we also share opportunities. So one that I would love to plug for your audience, this is mostly for older people, for college students. Mm-hmm. We have an internship at Blue Marble Space Institute of Science called the Young Scientist Program. And this internship, anyone in the world can apply as long as they're a college student. Now, for those who are younger, if you're in high school level or a younger person, there's still ways to get involved. Reach out to astrobiologists, to scientists and philosophers who interest you, and ask them if they have anything you can help them with. Get involved. Harsh, you reached out to me, and that's how we know each other. Because that's the way it works. When you reach out and you make connections, that's how you build your network for the future moving forward. No one's going to do that for you. Even if you go to university and you get a good degree, even if you complete a whole bunch of certificates, that doesn't mean anything really in the long run if you don't have a network, if you don't know people. You need to make those connections and speak to people. Let them know what drives you, what intrigues you, what inspires you. And then my final piece of advice is to find a mentor. A mentor is not just a teacher. So teachers are very important in our lives. We need teachers, instructors to help guide us. If you want to learn martial arts or meditation or science or art, it's good to have an instructor, but also having a mentor, someone who can help you when things get rough or give you guidance, give you advice, who's not going to tell you the answers, and they're not going to grade you. A mentor's job is to be there as a support for you, to help lift you up as you lift yourself up. And good mentorship can come in a variety of ways. A mentor can be someone from your family. It can be someone from your university or your school. A mentor can be someone you've met online who just has a little extra moment of time once a month or once every few months just to give you a little bit of advice, and who can tell you when an idea you have needs to be revisioned and reworked, or when an idea you have is actually so good you need to go share it now. A mentor will help you find the tools you need to become the best version of yourself you can be. And in astrobiology, in any scientific realm of study, in anything you do in your life, having a mentor is very crucial to that.
Yep. So like that was a wonderful answer, like regarding the mentorship and the programs for Blue Marble Space. So all the people who are watching us live, I have been a fan of Blue Marble Space, and I'll definitely post the links on the WhatsApp groups which are out there of Kalam Labs. So be in the groups, and we'll share the links about all the students who are above age of 10. We'll send out the links, and perhaps in the summer program, you all can register and be a part with and work under Dr. Graham Lau himself. And now, like, it was a wonderful session, sir. Like, I'm totally thrilled with the participation in the chat, over the views. It's a thrilling session. We have reached around 1,000 to 2,000, but this time it like totally went up quite well. So it definitely tells us that people, and kids especially, are quite curious. And on this channel, we like every day we host a session on 6 p.m. and we call great people like Dr. Lau himself and other people. I hope that it was a good evening for you, sir, as well. So what's like, how you're feeling about the whole session?
That was great. There's a lot of questions coming through in the chat. I'm very sorry that I could not answer that many of them. For those who are interested, you can find me online. My website is cosmobiota.com. You can find me on Twitter and Instagram at Cosmobiologist, on LinkedIn and Facebook at Astrobiologist. I'm happy to chat when I have time. I am very busy these days, unfortunately. I have noticed during the pandemic, I'm doing a lot more webinars and seminars and things right now, and I'm also writing a lot. And so I don't have as much time anymore, unfortunately. I really do try my hardest. If you send me a message on LinkedIn or on Twitter, I will try my hardest to answer. It can take me several weeks sometimes to get caught up to all my messages, though. But if you do try, I will do my best to answer. Again, reach out to everyone else out there in astrobiology. Find people who inspire you and give you passion from around the world, and just connect with them. And they might be able to help you then answer your questions, to learn more. But if you do have more questions about alien life, planetary science, philosophy, whatever it might be, feel free to reach out. I'll do my best to answer.
Yeah, we'll definitely share the links of Dr. Lau, both the LinkedIn as well as the Facebook, and also the website of Dr. Lau. We'll share the links at the WhatsApp groups, and definitely you can reach them out. And especially because there are so many questions, and usually, sir, in our session, we actually answer each and every question because the live audiences, it's around 100 to 200, like in the daily session in which I am there or Faraz is there. But this time there are so many questions, so we think that we'll have another session at 6 p.m. in which I'll be just taking certain doubts with my limited knowledge of science or things are there. And definitely we'll be sharing your links as well. So you can reach out Dr. Lau in whatever links we give out in the WhatsApp group. And thank you, sir, for this wonderful session. And it's a great honor to have you with us on the Kalam Labs.
Thank you.
Yep. Thank you, sir. So,
bye, everyone.
Bye, sir. So now, like people who are there, as Dr. Lau said, we are going to have another session tomorrow. Okay. So 6 बजे हम लोग के इतने सारे जो doubts आ गए हैं यहाँ पे सचिन शर्मा, कनिष्का जिंदल, तन्वय, and Aditya, Adya, and all the people who are there. We must tell you that कल हम लोग आने वाले हैं फिर से, and उसके बाद 6 बजे सारे WhatsApp ग्रुप में जितने भी लोग हैं सब लोग वहीं के वहीं रहना, क्योंकि डॉक्टर लाओ की जितनी वेबसाइट, उनकी लिंक, उनका लिंक्डइन, उनका नंबर, जारी जितनी चीजें हैं, जितने भी उनके क्वेश्चन से रह गए ना यहाँ पे, I can see millions of curious questions in the chat right now, and we'll definitely answer each and every one of it. Okay, so that's our word. By word, we can say that each and every question will be answered. Perhaps sir is a very great person. He's quite busy, but and Faraz sir, who's daily come on this channel and take up the curious doubts of all the curious little kids. तो कल हम लोग YouTube पे नहीं आएंगे, हम लोग Zoom call direct करेंगे, and with a batch of 100 or 200, we'll directly talk and play the game on ourselves. तो जो game देखा था अभी आप लोगों ने Kalam Labs Virtual Science Playground, उसकी direct access, we'll go to the moon, we'll go to the Pluto, we'll go to the Jupiter, we'll go to the Saturn, and उसके जहां जहां मन कर रहा सारे planets को explore करेंगे, and we will be there. So all the people who are telling us the questions, एक question answer होने वाला है, so you can get to know the questions, and WhatsApp group में please remain रहना, क्योंकि हम लोग को जो भी आपका सर्टिफिकेट और ऑल सारी चीजें होंगी हम लोग को पहुंचाने में आसानी होगी. So WhatsApp ग्रुप को मत छोड़ना. कल 6 बजे Zoom session होगा in which I will be there and Faraz sir will be there, who is actually from TU Braunschweig, Germany, and an NUS scholar. So perhaps my knowledge of astrobiology and his knowledge, eminent knowledge of physics and mathematics, can help us to answer all the wonderful questions जो कि आ रहे हैं. Yes, Mehek, Simran, Aditya, Suri, मैं इतने सारे नाम ले पा रहा हूँ. You have been doing a wonderful job. And now what I would like to tell you is that there's a like button and as well as a WhatsApp group. So this like button को please press कर दो if you have not pressed as of now, and there's a subscribe button as well. You can hit it. And tomorrow at 6 p.m. in the WhatsApp groups हम लोग फिर मिलेंगे. तो WhatsApp group को नहीं छोड़ना है, उसमें बने रहना है, और उसके बाद वहां पे हम लोग 6 बजे 7 बजे जो सेशन कराएंगे, पर्सनलाइज्ड Zoom पे सेशन होने वाला है. And each and every doubts which have been there, all the kids, I'm really sorry that Dr. Lau only could take a few of the questions. I'll personally take each and every question. Note it down. You have my personal number. आप WhatsApp कर देना, कुछ भी कर देना, but each and every question should be totally answered. Because being a kid, I really understand जब हम लोग के answer नहीं होते questions and Google पे जब answer नहीं मिल पाते, it's a very sad thing, right? So उसको हम लोग समझते हुए एक एक चीज को करते हुए tomorrow हम लोग फिर से मिलेंगे 6 बजे 7 बजे, जिस भी आप WhatsApp ग्रुप में हो सब वहीं बने रहना, एकदम बैठ के बने रहना. और उसके बाद हम लोग फिर मिलेंगे Zoom पे, और उसमें आपके साथ आने फराज सर. सो अभी मैं फराज सर को सिर्फ आपको टीजर दिखा दे रहा हूँ. ही इज फ्रॉम एक्चुअली एन US, Singapore and TU Braunschweig, Germany. So here he is basically with me as of now. We are at Mumbai. So Faraz, so perhaps you all can meet both of us tomorrow at 6 p.m, 5 p.m, 7 p.m, जितने भी टाइम पे होगा हम लोग आ जाएंगे. एंड ये जो इतने सारे क्वेश्चंस आ रहे हैं ना, तब ऐसे चैट पे नहीं होगा. इट विल बी डायरेक्टली कहाँ पे, डायरेक्टली ऑन द Zoom सेशन, one-on-one, face to face, mute कुछ नहीं होगा. Okay, if you like this idea, please hit the like button. There's a like button on the YouTube and a subscribe button as well. Okay, so be there at जितने WhatsApp ग्रुप बने रहो, सर्टिफिकेट सारे डाउट सॉल्व होंगे, and we'll be doing a wonderful session. Okay, so this is Kalam Labs. Note down on this name, okay? Kalam Labs is a place where actually क्या होता है, हर शाम को क्यूरियस चीजें होती हैं, ओके? जैसे आज एलियंस के बारे में डिस्कस किया, अगली बार पिरामिड्स के बारे में डिस्कस करेंगे, अगली बार माउंटेन्स के बारे में डिस्कस करेंगे. सो जितने भी क्यूरियस लिटिल किड्स हैं एंड ऑल द पेरेंट्स हु एस्पायर टू मेक देयर किड्स क्यूरियस, वंडरफुल, ब्राइट पीपल, we are there, okay? So हम लोग आपको ये नहीं कह रहे कि हम आपको कोडिंग एंड ऑल दीज मार्क्स एक्स ये कुछ नहीं. We are just inculcating curiosity. We are the most curious bunch of kids out here, not exactly me, but perhaps जो लोग मुझे देख रहे हैं. So we will be there live on the Zoom call, जिसका आपको लिंक आपके WhatsApp ग्रुप में मिल जाएगा, and हम लोग लाइव आएंगे फिर से. My name is Harshit Awasthi, and आपको पता है कि आपको क्या करना है. अगर नहीं पता है तो अभी देखो लिख के आने वाला है 3, 2, 1. Okay, so this is basically hit the button of like, इसको ऐसे like कर दो and subscribe कर दो, and please share with the friends. Dr. Lau के जितने contact details सब कुछ है, सब मिलने वाली है, okay? And जिन लोगों को गेम पसंद आया था, जिसको पता ही नहीं वो गेम क्या चीज थी, तो वो गेम भी मिलने वाला है. वो पूरा गेम जिसमें आप सैटर्न, जुपिटर, प्लूटो, मार्स, वीनस सब जा सकते हो, वो सारे गेम के ऊपर हम लोग साइंस पढ़ेंगे. तो ब्लैक बोर्ड, चॉक, डस्टर, पेन, नोटबुक के जमाने गए, अब नया जमाना है, गेम पे पढ़ाई होती है. And that game which has been created by Shashak sir, who is actually a AIR 540. तो IIT JEE आपने सुना होगा. So he is my friend Shashak. We are actually living out of Bombay, and हम इन्होंने ही पूरा गेम बनाया था, and उन्हीं के कारण ऐसा गेम बन पाया. So kudos to him. He's actually इनके गेम को national, international level पे काफी सराहना मिली थी. Recently, Finland government worked with us, and like they declared our innovation as the top edtech innovation of 2020. So with 30,000 votes, जो गेम आप देख रहे थे वो पूरे 30,000 votes internationally we won it, and that was created by this man जो कि क्या कहते हैं 540 AIR लाया था अपने टाइम पे, and this person जो कि NUS सिंगापुर and TU Braunschweig Germany, लोग इनको भरा सर कहते हैं. हम तीनों पूरे हफ्ते we'll take direct Zoom classes, we'll give you the Zoom link, and we'll give you all the people. Okay, so you know one thing, ये जो भी आपको करना है आप कर लो, सब्सक्राइब, लाइक एंड शेयर, एंड सारी व्हाट्सएप ग्रुप में सब दबा के बैठे रहेंगे, कोई कहीं नहीं जाएगा, एंड सर्टिफिकेट्स, काउट्स, क्वेश्चन सारे एक एक सॉल्व होंगे. तो जैसे मैंने आपको पर्सनली सारी चीज करी थी, अब फिर से हम लोग पर्सनली करेंगे. थैंक यू, बाय बाय, टेक केयर, एंड वील शेयर द डिटेल्स. एंड एक चीज याद रखना, क्यूरियोसिटी इज द सुपर पावर ऑफ किड्स. सो अगर कोई उनसे बोले तुम्हारी सुपर पावर क्या है, बैटमैन सुपर पावर, इसकी सुपर पावर लाइट, सब आपकी सुपर पावर है क्यूरियोसिटी. क्यूरियस बने रहे, हेल्दी बने रहे, एंड तब तक के लिए गुड बाय, शब का खैर, एंड क्या कहते हैं टीवी में. Okay, so bye bye. We can end the stream now. Parash, Shashak, bye.
Bye everyone. See you tomorrow.
Yeah. WhatsApp group.
WhatsApp group में सब लोग रहना. Certificates, everything will be there.
Yup. Bye.
Bye.